Continuing on with our parallel lines concept, you are going to move to the next learning target, which is writing equations of parallel lines. So how it's going to be worded, it's going to say create an equation that's parallel to a given line and goes through a particular point. So there's three main steps to do it. It is pretty technical. The biggest thing is you need slope. That's step one. You identify the slope. This is where you are going to have to get y alone. And I want you to underline that like 1,000,000,000 times. That is the most important thing, as we described in previous units and slides and videos. You cannot analyze slope unless y is all by itself. Then the second thing you'll do is take the point they give you and use the slope that you just found. And then the third thing that you do is use point-slope equation to get y alone. So let's just apply this. Let's create a line, an equation of a line that's parallel to y equals 3x plus 2, and it goes through the point 3, 2. What I want you to recognize is it's parallel to this given line. That means it's not that given line, because parallel lines mean that they increase at the same rate or have the same slope. They are not the same line. A same line would look like right on top of it. It would be the same equation, but it's not. It's parallel, which means that it has a different y-intercept. So the first thing I want to do is figure out my slope. Here, y is by itself, so my slope is whatever is in front of x, which is 3. My slope is 3. The second thing I do, and this was our lesson in 5.4, I use the point it tells me. It says it goes through the point 3, 2, and now I know that it has a slope of 3. I just calculated that in step 1. And then the third thing I do is I use point-slope form to create the equation of this line. Point slope is y minus the y you're given is equal to your slope times x minus the x you're given. And then you just got to take about 40-ish seconds and pretty this up a little bit. You need to isolate y again. So I get y minus 2 equals 3x plus a negative 9. Notice I plussed a negative there, so I knew that 3 and negative 3 is actually a negative 9. Now I'm going to plus 2 to get y by itself. And you get y equals 3x plus negative 9 and 2 is negative 7. And then you have to pretty it up one more step and turn your plus and negative back into subtraction. And this is the equation of my line that's parallel to the first line that goes through the point 3, 2. Notice that they are not the same line. They have the same slope. Notice they have the same slope, 3 and 3, but they're not the same line. They have different y-intercepts, which will show that they are parallel lines. Okay, let's do it again. I want to create an equation of a line that's parallel to this line, and it passes through the point 1, 4. Again, parallel means it's not the same line. It just is parallel to it. So parallel means they are different y-intercepts, but they have the same rate or slope. So my first step, I got to figure out my slope. What is the slope then? Here y is by itself, so I can analyze the slope. Looks like my slope is negative 3. The second thing I do is use the point it gave me, 1, 4, and the slope that I just identified. So I know the equation of this parallel line goes through the point 1, 4, and it has a slope of negative 3. And then the third thing I do is use point-slope form, because I'm given a point and a slope, so I need to do point-slope. Y minus the y you're given is equal to your slope times x minus the x you're given. I'm going to go ahead and plus a negative over here on the right-hand side. My purpose for that is because I see I'm going to distribute a negative 3. Y minus 4 equals negative 3x plus a positive 3. Negative 3 times negative 1 is a positive 3. We're going to add 4 so I can get my y by itself. Y equals negative 3x plus 7. This is the equation of a line that is parallel to the line that was given to me and goes through the point 1, 4. Again, you can identify that they're parallel because they both have a slope of negative 3. Parallel lines have the same slope. Okay, so this isn't in your notes, but I want to make sure to teach you how to handle writing an equation of a line that's parallel, given that it goes through a particular point, with us having to get y along. Notice in the top 2 examples, y was all by itself. I'm not going to show you, but if you look at your top 2 examples, y was all by itself. We cannot analyze slope. There is no way of knowing slope unless y is alone. If y is not by itself, y equals mx plus b, then you have no way of knowing the slope. So, let's say that we're parallel to 4x minus 2y equals 4, and I go through the point 1, 5. I want to write an equation of a line. Well, it's still the first step. I need to know, hey, what's my slope? Well, don't put 4. It is not 4. It's not what's in front of x. You have to get y alone first. So here we have to do some extra work to identify our slope. I'm going to plus a negative here just so I know that's a negative 2 in front of y. And then you go ahead and use that little algebra wrap to solve for it. We're going to add or subtract the x term. I'm subtracting 4x to both sides. Now I have negative 2y equals negative 4x plus 4. Then I'm going to divide by the coefficient of y. There I go. Negative, that cancels out the negative 2 coefficient, so I get y equals a positive 2x plus a negative 2. Okay, don't think you're done. This just tells me step 1. All of this algebra is still in step 1, where I'm trying to identify what the slope of the parallel lines is going to be. It looks like my slope is 2. Now compare that. Those of you that think the slope was 4, notice that it was not 4. The slope is actually 2. You have to get y alone first. And then step 2, I use the point that I know the line goes through, which is 1, 5. And now I know my slope is 2. The third thing, I use point slope form. Notice I'm given a point in the slope, I use point slope. Y minus the y I'm given is equal to my slope times x minus the x I'm given. And plussing a negative, I always do that when I'm distributing, or if I'm going to be solving. So then I get y minus 5 equals 2x plus a negative 2. Add 5, and you get y equals 2x plus negative 2 and 5 is 3. That is the equation of the line that is parallel to the initial equation. Notice that the initial equation was actually in standard form. But in order to create parallel lines, we have to know slope. So you have to convert it from standard form to slope-intercept form. Again, first thing I said, do I have my slope? I noticed that y wasn't alone, so I had to go through, get y alone. So this is still all part of step 1. I identified the slope, still part of step 1. Then I used the point they told me it went through and the slope I just calculated. Then I used point slope form and I simplified everything up to get my final answer in slope intercept form. Notice that they are parallel lines because they have the same slope, but they have different y-intercepts. So if I were to graph these, I have on the first one, I'm just going to make a rough graph. The first one I would go through -2 and then up 2 over 1, up 2 over 1, down 2. So my first line would look something like this. And then the line I created, my final answer down here, I intersect the y-axis at 3, and then up 2 over 1, up 2 over 1, down 2 other way. And as you can see, they are parallel lines. They will never intersect. And you can always check your answer like that too. If you graph both of the lines, they should look like they will not intersect.